Hi, I'm Philip, and in this video I will show you, I would say, the lazy way of modifying 3D scanned parts, or fixing 3D scanned parts and then printing them. So the normal approach would be to do a complete reverse engineering of the part in Quicksurface. So you have the scan as a STL file, then you recreate the part in Quicksurface, and then you can modify it as a CAD part or print it. This takes time, and for smaller fixes or smaller adjustments, this may be a bit overkill. So yeah, I chose the easier way, and a way with less resistance. And what was my problem? So I have a coffee maker, and the coffee maker has a brewing unit. This is the brewing unit from the side, and on top of the brewing unit there is like a pivoting arm that pushes the ground coffee into the waste bin after the coffee is made. So it's normally like a bracket or a coffee pad, it looks like a puck, but as you can see over time it aged a bit, or it deformed a bit, and there is now this gap between the brewing unit and the arm. And due to this gap, there are like coffee grounds everywhere because the arm doesn't completely push the grounds off, as you can see here. So this was my my problem. And to fix this, I just wanted to close this gap with a redesigned part, and then hopefully fix the problem. I started with 3D scanning the parts, of course. So I first scanned the isolated parts because I don't want to recreate it. I have to try to capture it as much as possible. For scanning, I used the Sermoon P1 scanner, especially because it has the single line mode. So in the scan I will show you shortly, you can see that the single line mode is necessary for the mounting holes, and especially from the bottom side. And I also scanned the arm installed in the brewing unit to have a dimension of the gap that I need to fill. For scanning, as you can see here, I just placed my marker cards that are basically metal business cards with marker points glued on them, and marker geometries on the table, and just scanned on. I chose a scanning resolution of 0.1 millimeters, and the final scan, as you can see here, of the arm came out quite nicely. I scanned the arm in two parts. So I have the top part, so face down, and as you can see it's at 0.1 millimeters, and I managed to capture the whole inside of the hole of here on the top. Inside the holes they are a bit rough, generally the part is a bit rough. This may be due to me using automatic exposure. So it was slightly overexposed in automatic exposure, because for the standalone part, I scanned on the black turntable, and therefore it tried to adjust the exposure for the turntable, but it still was fine. So I didn't see any need for using manual exposure. And the second scan is even more impressive, I would say. As you can see here, firstly, I trimmed away some of the overlapping areas that weren't captured good enough on the second scan, just so the first scan can fill in all these gaps, and I have a clear part, a clear mesh. And here at the bottom, it now gets quite nice. So as you can see here, the mounting geometry is quite complex. We have this pin, it gets pushed on, and there's the flat face, we have this cutout, and we have these cutouts where a spring is situated. So a spring to keep the arm in the back position when it's not needed. So basically for such a scan, single line mode is a must. So without single line mode, I guess couldn't be captured. And Sermoon P1 worked quite fine in this mode. So I used the P1 in wireless mode connected to my PC, because if I'm scanning small parts and I'm already at my workplace, there is simply no need to do the standalone scanning, because first, if I do standalone, I need to transfer the whole project to my PC, which is extra steps. Whereas with this approach, I can just like scan directly on the PC, and it's of course faster. So in wireless connection mode, you get 80 FPS scanning speed in laser mode. In the standalone mode, you're more likely somewhere between 30 and 60 FPS, so 30 for the crossline modes if you're like capturing very complex geometry, high resolution, and 60 for like parallel and single line mode. But I hope they can improve the stability a bit in the future, or future updates. You can get even higher speeds in the wired connection with the PC. There you can reach up to 100 FPS, and it also reaches the claimed FPS. So continue with the scan. So I just did 2 scans and then aligned the scans to each other and created a mesh. For the mesh, I just used the default settings, and I manually filled a few holes. So in here, like in the very deep crevices, there were some holes, and I just filled them with the manual hole filling tool. But in the end, I just filled all holes, so I get a 3D printable manifold part. For the coffee, for the attached part, I did the same. And now, as you can see here, I continued in Quicksurface. I started with loading in the scan of the attached arm. So as you can see, here's the arm on the brewing unit, and we quite well see the gap. And then I imported the single scan of the arm and aligned it to the attached one. The attached one was first oriented to the coordinate system, as you can see here, with the prepare scan function. Theoretically, it's not needed, but it's just easier to work with. So you don't need to align it for such tasks, but I only see benefits, and it's quite a fast process. And what my approach was for this, I just wanted to create like a small shim here that is then combined as a mesh with the original arm, and I can just print both of them combined, so I don't need to reverse the whole part. So with this approach, it only took like 10 minutes of modeling and not maybe 1 hour for the whole reverse engineering. For this, to reach this goal, I first created a plane on the bottom side. So as you can see here, I first created a plane on the bottom side of the arm with by extracting the primitive, so the face of this, and fitting a plane to it. And then I created a sketch. So this is the single sketch that I need in this project. It's basically just an outline sketch of the shim I want to model. And I can then extrude this one. So maybe let's pull the timeline a bit back. So here you can see I have the sketch as first part, then I can directly extrude it. And now the next step is, the next step is filleting, a few fillets. These are like unimportant. But now the important part is I fitted a plane to the face of the coffee grinder, sewed the plane. So you need to sew planes to use them for trimming operations. And this can be done in the surfacing and then sew surface option. And the next step is just trimming this part with this part. So you basically select both of them, and then you can perform a trim operation. And the final part will look like this. So this is already the shim that we will need. And then I can just again create a fillet here in the front and a few more fillets, as you can see here. And now this is my part. I could theoretically now direct export this step file, but I'm not needing this one. I need a combination of these two. And to achieve this goal, you can directly select a solid in MeshMaker, in Quicksurface, and use the option Create Mesh. You get input a tolerance, so how close the mesh needs to be to the body. If you input a lower value like 0.005 millimeters, you will simply get a lot more triangles in the final part. And so we can now see we now have a mesh of these of my newly designed part, and this can directly be combined with the 3D scan. So now let's hide the attached part. And maybe let's now look at the combination of both. I can redo the combination for this. I just duplicate the mesh I'm starting with, and now I can select both of them and use the merge command. It's important, if you merge, it's not like a really clean mesh, I would call it. So if you can now look at the edit scan, you're seeing that they are still two individual meshes, but this is actually not a problem for 3D printing, because now if I export this part as a mesh, so here under export scan data, I can just open it in my slicer. So this is the quality slicer, and as you can see here, it's slicing fine. So as you can see, so there is like also no break in the geometry, and I just printed them from Acer filament, and the final parts looked also quite fine. So this is the printed part from Acer, and this is like the new part attached, where you can see this now the gap is like significantly reduced. I may even lower it a bit or make it extrude a bit further, so the gap is even smaller. And please don't remind me, I know that this is not like the hygienic methodology. I'm regularly cleaning the coffee machine and the grinding unit like once a week, and this is only like a temporary fix until I get the motivation to buy a new coffee machine somewhere mid this year. But I hope you learned something, or you could get some inspiration on how to do like quick fixes. So basically, to summarize, I just scanned the part. I then constructed the additional parts as a traditional body in Quicksurface using like regular reverse engineering and designing techniques. And then I can just mesh my body, manually create body, and combine these meshes. Of course, you can also, like before combining, edit your trim parts away. So if you have like a broken part, you could theoretically here on the lower side just use a trimming tool to delete all the unnecessary faces. And therefore, I hope you enjoyed, and until next time.